We will now see how to do this one. That is, we have 2x minus 5, the quantity squared. So first of all, this is equivalent to 2x minus 5 multiplied with itself, that is 2x minus 5. So we can now see that it's product of two polynomials, that is the same polynomials multiplied once again. So what are the methods that we discussed from the previous problem, that is the FOIL method, the box method, or the distributive method applies to this problem also. And in fact, there is another method also which we are going to discuss, that is using the identities method. First, we will multiply this using the FOIL method. That is, so we have to take the first 2x multiplied with 2x, which is 4x squared. Then the outer, which is 2x times negative 5, which is negative 10x. And then the inside terms, which is negative 5 times 2x, and that is also negative 10x. And then the last, which is negative 5 times negative 5, which is positive 25. We'll simplify this further. We have 4x squared, that's the only term. And then negative 10x, they are like terms, which is negative 20x. And finally, we have this number plus 25. And so, therefore, this is the result of expanding this 2x minus 5 quantity square, or the product of 2x minus 5 when multiplied with the same polynomial once again. Now let's see how to do this using the identities method. So whenever we come across expanding 2x minus 5 quantity square, that is in the form of a minus b quantity squared, this is equivalent to a squared minus 2ab plus b squared. We can utilize this identity. So I'm going to write down this product, that is 2x minus 5 quantity square, in the same form. And this means we can now see that our a is 2x, this is our a, and then the b is the 5, this is b. So basically we substitute into this identity, and so therefore if you apply this identity, a squared, which will be 2x, the quantity square, and then minus 2ab. So this is minus 2, and then a is 2x, and then b is 5. Then plus b squared. So it is b is 5, so it is 5 squared. Now we can simplify this further. So this is 2x quantity square, that will be 4x squared. And then we have to multiply these three products, 2 times 2x, and then with 5. First we multiply the numbers. 2 times 2 is 4, 4 times 5 is 20. And we also have this x, so this is going to be negative 20x. And then finally we have this 5, and that is to be squared, which is 5 squared is 25. So this is what we get when we expand this 2x minus 5 quantity square. Compare this with the first method, we got the same result. Now let's see how to multiply these polynomials. So here we have the first polynomial, which is 2x, and then the next one is 4x squared minus 3x plus 2. So basically it's a trinomial. The first one, it is a monomial because it has only one term. The second polynomial is a trinomial. And so when we do this, we just have to distribute the term 2x with all the terms in the second polynomial. So we are going to multiply 2x with 4x squared minus 3x plus 2. So we take this monomial and multiply with all the terms. Basically, we distribute like this. So the first one is 2x multiplied with 4x squared, and then take the 2x once again, multiplied with negative 3x, and then take the 2x term once again, multiply with the last term, 2. So we just have to simplify this by multiplying each products. So this is 2x times 4x squared. Remember, the number multiplies to 2 times 4 is 8. And then x multiplied with x squared, according to the power rule, it is x cubed. And then the next one is 2x multiplied with negative 3x. So it is negative 6x squared. And finally, 2x times 2 is 4x. And so this is the result of the product. The last problem that we have here is the product of two polynomials. The first one is x minus 3. So basically this is a binomial. And then the next one is x squared plus 2x minus 3. And this one is a trinomial. So we have discussed several methods when multiplying polynomials. That is the FOIL method, the box method, the distributive method, and then the identities method. Let's see which of the methods will apply when multiplying a binomial with a trinomial. We cannot use the FOIL method because the FOIL method is best suited when we multiply two binomials. So box FOIL method we cannot use. Then we have the box method. So we can definitely use the box method while multiplying any different types of polynomials. And then the distributive method which we can use. However, we don't have any suitable identities method to multiply these two polynomials. So we don't have identities method. Here we are going to solve using the box method. So first we need to identify what type of box or the dimensions of the box that we need. So since it is a binomial, the first one, we have two terms in this. And then the second one is a trinomial. So it has three terms. So basically our box has to have 2 times 3 equal to 6 entries in it, which means we have to create either a 2 rows, 3 columns box or a 3 rows or 2 columns box. So I'm going to create like a 3 rows and 2 column box. This is the first row. For the second row, then we have 2 columns. This is 1 and 2. Just remove this. So now we have to write down the binomials, terms of the binomials. First, we write this x and negative 3 here. And then the terms of the trinomial, we can write this here, x squared, 2x, and negative 3. So we have x squared multiplied with x, which is x cubed, and then x squared multiplied with negative 3, which is negative 3x squared. So we keep on filling the entries or doing the products. So 2x with x is 2x squared, and then 2x with negative 3, which is negative 6x. Then finally we have negative 3 multiplied with x, which is negative 3x. And then finally negative 3 times negative 3, which is negative 9. Now we have to take the terms in the box and give it in simple form. So we will identify the diagonal terms, which are going to be like terms. These are the diagonals. First, I write this only cubic term. So it is going to be x cubed. And then the first diagonal which is 2x squared negative 3x squared, and that simplifies to negative x squared, and then negative 3x negative 6x, which is negative 9x, and finally we have negative 9. So this is the product that we get after multiplying the binomial with a trinomial. Now we will see how to do it using the distributive method. So I'm first going to write down the polynomials. We have x minus 3 multiplied with x squared plus 2x minus 3. We do this using the distributive method. So in this method, we take each terms from the first polynomial and multiply with all the terms in the second bracket. So first I'm going to take this first term, which is x. I need to multiply it with the second polynomial. So we have to write down the second polynomial as it is. We are done. Now we take the second term in the first polynomial, which is negative 3, and this has to be multiplied with the second polynomial. So once again we write down the second polynomial, which is x squared plus 2x minus 3. Now we have to distribute each of the products. So this will be x times x squared, which is x cubed, and then x times 2x, that is 2x squared, and then x times negative 3, that will be negative 3x. We're done with the first product or the first distribution. Now let's do the similar thing for the second. This is negative 3 times x squared, which is negative 3x squared, and then negative 3 with 2x, which is negative 6x, and finally the last product is negative 3 times negative 3, which is positive 9. Now we can simplify this further. So let's identify the like terms. The x cube it is the only term, so we write it once. Then we have this x squared terms, which are 2x squared negative 3x squared. That simplifies to negative x squared. And then we have negative 3x negative 6x, which is negative 9x. And finally we have positive 9. So this is the result that we get when we multiply binomial with a trinomial. Let's compare it sorry for that. Let's compare it with the result that we got. So they are almost they are exactly the same. X cubed minus x squared minus 9x minus 9. So what we got in this method is also correct. And once again, the user or the student can choose any of the methods that they are comfortable with.